All right, let's get right into it. We're about to tackle one of the most absolutely mind-bending ideas in all of science.
I mean, really think about it for a second. What if our entire universe, everything we can see, every star, every galaxy, what if it's just one tiny piece of something much, much bigger? That's the core question, right? And it's the central idea behind the theory of the multiverse.
So, here's what we're going to do. We're going on a journey through this pretty wild concept. First, we'll get a sense of our own cosmic neighborhood. Then we'll look at how new universes might actually pop into existence. We'll even try to categorize the different kinds of multiverses people talk about. Then, the big one, we'll hunt for evidence. And finally, we'll get to why this whole idea might be the key to figuring out why we're even here.
Okay, first things first. Before we can even dream of looking for other universes, we've got to get a grip on our own. You know, what are its limits? Where does it end?
So here's the thing. Our universe is old, right? About 13.8 billion years old. And light, well, it doesn't travel instantly. That means there's a cosmic speed limit on how far we can see. The light from anything further away just hasn't had time to reach us yet. That sphere of what we can see, that's our observable universe. It's huge, for sure, but, and this is the important part, it might not be the whole story.
And this is where it gets really interesting. What if space itself just keeps going forever? I mean, if that's true, the implications are just massive, and it perfectly sets the stage for the very first type of multiverse, which is actually the easiest one to wrap your head around. You know, the idea of parallel universes isn't just something from science fiction. It's not just a cool what if. It actually pops right out of our best scientific theory for how our own universe got started. We're talking about a theory called cosmic inflation. The idea is that in the tiniest fraction of a second after the Big Bang, the universe just exploded in size. It went from smaller than an atom to absolutely enormous, almost instantly. And this isn't just a guess. This theory explains a ton of stuff we see in the cosmos today. But here's where the math leads to something incredible. It suggests that this inflation, it might never totally stop. The larger space, this metaverse, could just keep inflating forever. But little pockets of it can slow down, cool off, and bubble off on their own. The best way to picture it is like bubbles forming in a rising loaf of bread. Each one of those bubbles pinches off and becomes its very own universe, with its own Big Bang. And our universe would just be one bubble in this massive, endless cosmic foam. Okay, so we've got a lot of different ideas flying around. How do we keep them all straight? Well, thankfully, a physicist named Max Tegmark came up with this really smart way to organize everything. Think of it like a field guide to the multiverse, with 4 distinct levels of parallel worlds. Let's quickly run through them. Level I is pretty simple, relatively speaking. If space is infinite, then eventually everything has to repeat. Every possible arrangement of atoms will happen again and again. So somewhere out there, way beyond what we can see, there are other regions just like ours. Level 2? That's the bubble universe idea we just covered, where each bubble might have totally different laws of physics. Now, level 3? That's where we get into the weird world of quantum mechanics. We'll get to that in a sec. And level 4 is maybe the most out there idea of all, that any universe that can be described by mathematics actually exists. If the math is sound, the universe is real. Wild stuff. Okay, let's zoom in on that level 3, because this is where your brain really starts to melt a little. It's based on something called the many worlds interpretation of quantum mechanics. And what it says is that every time there's a quantum event with more than one possible outcome, the universe splits. It branches into separate realities for each and every outcome. So yeah, that means there is a very real universe where you clicked away from this explainer a minute ago, and another one where you had pancakes for breakfast instead of cereal. Every single possibility plays out in its own parallel world.
And the implications of that are just bizarre. I mean, look at this quote. It's not just about tiny little changes. If every quantum event creates a new world, the number of parallel universes is just, it's beyond comprehension. It would contain every possible version of reality you could ever imagine, and a whole lot you couldn't.
So this all sounds absolutely incredible, right? But it brings up the elephant in the room. It's the one question that really divides scientists. Can we prove any of this? Is there any evidence at all? And look, the short, honest answer is no. Right now, there is no direct proof. The multiverse is still a hypothesis. We've never seen another universe, never touched one, never gotten a signal from one. But that doesn't mean people have stopped looking for clues. Probably the most famous piece of potential evidence is something called the cosmic cold spot. It's this giant patch in the sky, in the afterglow of the Big Bang, that's just a little bit colder than all the models say it should be. Now, there could be a perfectly normal explanation for it, but some physicists have wondered, what if it's a kind of cosmic bruise, a scar left over from when our baby universe bumped into another bubble universe way back in the day?
And this really gets to the heart of the whole debate. On one side, you have scientists who say, look, the multiverse isn't some crazy idea we just made up. It's a natural result of our best, most tested theories, like cosmic inflation. But on the other side, you have critics saying, hang on, if you can't test it, if you can't prove it wrong, is it even science anymore, or is it just philosophy?
So, if it's maybe untestable, why do so many brilliant physicists take it so seriously? Well, it's because the multiverse might just be the best answer we have for one of the biggest puzzles in all of science, the puzzle of why we're here at all.
It's this thing called the fine-tuning problem. When we look at the basic numbers that run our universe, the strength of gravity, the charge of an electron, they seem to be perfectly, and I mean perfectly, dialed in to just the right values to allow for stars, planets, and life. If you tweaked any of them, just a tiny bit, the whole thing would fall apart. No stars, no chemistry, no us. So the question is, how did we get so lucky?
Well, the multiverse provides a really elegant answer. If there are countless other universes out there, and they all have different random physical laws, then it's not surprising at all that a few of them, just by pure chance, would have the right settings for life. It's not luck, it's just a numbers game. Like a cosmic lottery. With enough tickets, someone's bound to win.
And if you look at it that way, our existence isn't some great miracle. It's a statistical inevitability. Of course we find ourselves in a universe that can support life. We couldn't be anywhere else to ask the question, could we?
So, where does that leave us? Well, we don't have the final answer yet. The idea of the multiverse is incredibly powerful, it's elegant, and it seems to follow logically from our best theories. But it's also right on the bleeding edge of science, really pushing the limits of what we can actually know about, well, everything.
So I want to leave you with one last really provocative thought. If that level 3, the quantum multiverse, is real, it means that every choice you've ever made, every path you didn't take, well, it was taken by another version of you in a parallel world. Our reality, the one we experience, would just be one single branch on a truly infinite tree of possibilities, and all of them are just as real as ours. Now that is a thought that can really change the way you look at everything.